Hi everyone! You know that the modular approach of ggplot allows us to progressively add all our knowledge of spatial visualization in different layers to create complex thematic maps. However, these enriched thematic maps also require to contain text or labels to specify certain places of the map, and also they require important map elements like scale bars and north arrows. An example of all of this is in this figure. Today you are going to learn how to manage the ggsspatial and the ggsflabel packages to add all of these additional elements. Let's start. Okay, so as usual, you can pause the video here and read through the learning objectives of the lesson of today. Our goal today is to answer to the following question: how are the Tier 3 hospitals distributed in the western province of Sierra Leone? For this, we are going to retrieve real hospital information from public repositories, and we're going to achieve this with our first point. So the AfriHealth sites functioned from the package of the same name allow us to get the coordinates of African health facilities from different sources. In this example, we are going to retrieve health facilities from Sierra Leone available in the WHO database. Today, we are going to access to health facilities available in the WHO database. So, if we want to retrieve information from Sierra Leone, first we need to specify that we want information from this country and the data source, the WHO database from Sierra Leone. Okay, so we can take a look at the database. It is an SF object with a coordinate reference system of WGS84 with several columns that contains the country, the administrative region, the facility name, also the tier level, and the geometry column. Let's put this in practice. It's your turn to access all the health facilities of Zimbabwe from the health sites data source using the AfriHealth sites function. Remember, we're asking for the country and the data source. So the 3-tier health delivery classification specifies that the highest tier is responsible of the most inpatient services as well as teaching and research missions. So to answer to our question, we're going to keep the tier 3 health facilities inside the western province. And for this, we need to recall our understanding of dplyr functions. So we have downloaded the health sites database, and first we may want to filter the western province. Let's filter all the administrative regions that have the western province. For this, it would be relevant to identify how are these information available in the database. So let's run this piece of code and see how the western area is denoted. So it is western area. Okay, so we have the western area here, and then we need to keep the tier 3 facilities. So tier equal 3. Okay, so we raise this and check if this is okay. So we already have all the admin and all the health facilities that belongs to the tier 3. Okay, so let's run this whole chunk. Okay, all of these sites belong to Sierra Leone, and for this reason we're going to locate these points within the country boundaries of Sierra Leone. So if you recall, we can use the geo boundaries dataset and specify the country, Sierra Leone, and also the administrative level. In this case, we're going to just download the whole country, but we need to get the province boundary. So let's use the administrative level 1. And let's see if we have the information that we need. Okay, so here we have the names of the shapes: southern, eastern, western area, and northern area. So we are okay with this data frame. So now let's create a map with our Sierra Leone object of the country boundaries and province boundaries with the health sites that we just downloaded. So for this, we can remember our understanding of layers. So we can add different layers of geom_sf objects. So first, let's add the geom_sf object to the data that we want in the background. In the background will be useful to have the country borders. So let's call here the Sierra Leone object. And then let's add one more layer of geom_sf with the other data, the SLE health sites set. Remember that the health sites set is a subset of health sites that belong to tier 3 and the Western province. So let's check if this map appears correctly. Nice, we have the whole country and within the Western area, the points of the health sites. Nice. So now let's use the ggSF function to zoom into the area of interest to update the extent of the map. So we can replicate here the code that we wrote above, right? Plus the update of the map extent using the ggSF function, delimiting the x-axis of the longitude and the y-axis of the latitude. Okay, so let's run this piece of code. We now have the points within the Western province and the map with the right zoom. Okay, let's recap. SF objects can handle on-the-fly the coordinate systems, both in projection and extent. Now let's move to our second point. So we're going to now add scale bars and north arrows with the ggspacial package. To accomplish this, we're going to use the annotation north arrow function and the annotation scale functions. Functions really easy to recall. And let's complement our map. We already filled the country map with hospital counts and the map extent. And now let's add these annotation skills. Let's use the annotation skill and north arrow and the annotation scale bar. Yeah, annotation scale. So to this code, we also need to add one argument, which is the location. And we are going to try to put it in the top left side corner of the map, and for this scale we're going to use the bottom left side of the map. And let's run this piece of code. Okay, so now we have the north arrow in the top left side of the map and also the scale bar not to the top left but in the bottom left. The locations are by default in the bottom left, but we can specify them within the location argument. We need to use these combinations of two letters. For top right is the R and for bottom left BL, and for the other locations use the letter appropriate to the direction. Okay, so now it's your moment to practice. So to this ggplot map with the Zimbabwe admin1 object, add a scale bar located in the bottom right of the map and a north arrow in the top left. So let's start. Okay, so now let's look at a little side note. The north arrow style can be adjusted with the style argument, and the scale distances are by default set in kilometers. So now let's move to our third point. Let's add hospital names to the map. So for this, we're going to use functions from the ggsflabel package. So the first one is the geom_sftext. So if we run this piece of code, we're going to see how the column of the health facility set data, which is called facility names, could be added to the label argument. If we use the geom_sftext function, we obtain this output. A disadvantage of this output is that we have a lot of names overlapped. So this is why this is not satisfactory, and too many overlap points difficult the possibility to read this object. So the ggsflabel is inspired in the ggplot package, which allow us to deal with this overlap of objects, in this case with SF objects. Let's replace the geom_sftext with the geom_sftext repel function. So to exemplify this, let's notch the facility names and connect them with their locations. To accomplish this, we would need to use the geom_sftext repel, and as a mapping, we can specify that the label that we want to use is facility name. Okay. So this new configuration have increased the readability of the content in this map. So let's practice this. Let's use the Zimbabwe Hospitals object, which contains all the hospital facilities of Zimbabwe. And with this object, let's add the name of these facilities as text without overlaps using the geom_sftext repel function in this template. So go ahead. Recall that the ggRepel package have a lot of arguments to improve the output of visualizations. You can use the size argument to increase or reduce the size of the text. Also the type of font, the force argument to force a repulsion between overlapping text, and the box padding of each text. Here we have pasted a complementary code within the geom_sftext repel to reproduce how our previous map would change given these new configurations. Okay, we still have some kind of overlap, but this can manage if we increase the size of the map. If we add this layer to our current map, this layer of points to our current map, we can obtain something like this. We had our country and hospital points, plus our map annotation and coordinate SF functions. Now we have added all of this piece of code: the geom_sftext, the object, the label, and a lot of different characteristics that belong to the ggRepel function. Okay, so here we have our draft map. We have the scale bar, the north arrow, and the text labels. If we would like to increase the readability and avoid overlap between different objects, for example, we could put the north arrow to the top right. In this case, we have a space for all the names to be read without overlaps. Okay, so now let's add the province labels with the geom_sflabel repel. Okay, so these names are available in the shape name variable of the Sierra Leone. So recall, let's look at the table of this function, and we need to retrieve the information from this variable. So in our country map, for example, we can, with this, we're going to create the basic country map, and then to add the province labels, we can use our function of interest of this part of the lesson, sflabel. And within the static function, use the shape name. So, this is shape name. Okay, so now we have added these labels, and these labels also have the interesting feature that they avoid the overlaps. New practice. The Zimbabwe admin one object contains the boundary of all the provinces of Zimbabwe. With this, create a ggplot map of Zimbabwe with labels of the names of each of its provinces. Let's go. Now, since our map is focused in the western province, we would like to drop the labels that do not belong to the site that we are looking at. So for this, we can use the plier again. So let's start. If we provide the labels, we need to use geom label repel, and in the statics, just label equal shape name. Okay, and the same as above, now we need to specify the data and specify the mapping here. This step requires first specifying the data of the Sierra Leone and then specify the variable name available in the dataset. If we run only this piece of code, we are going to see that we have this eastern label that do not correspond to any of the areas of the polygon in the background. So that's why we recommend to drop it. So let's filter all the shape name different to eastern. So let's see if this runs. Yeah, we have the southern, western, and northern, but not the eastern one. Okay, if we run this whole piece of code, we now do have only the labels for the areas that are visible in this part of the map. Okay, now with all of this knowledge of accessing hospitals, adding scales, text, and labels repel between the to avoid the overlaps, we can make a final map, putting everything together, adding district boundaries, and to this we're going to add more information. We're going to add the boundaries field, we're going to add district boundaries field by area, and also field sites recorded with GPS devices. For this, we're going to read these two different data sources. Remind that we are able to use dplyr functions with the GSF package, and also we're able to transform points to SF objects. And now let's run this code. We have generated this map, adding a lot of different information, adding the country map in the background, adding the province labels, avoiding overlaps, the hospital points, the hospital names with repel text, the map annotation, the map extent, and also the recently included code, which are the districts filled by area, and also the field site points. Getting this final map. Okay, so now let's wrap up. Today you have learned how to add layers of ggplot to in a really straightforward way. As long as data is properly stored as an SF object, it's easy to be added into this workflow. Consequently, adding the annotations and labels to our ggplots follow the same rules. And additionally, the calls of geomsf in the right place of the ggplot2 workflow allow us to have the best map. So now, hopefully, you feel more comfortable with concepts like adding labels, adding text, or map annotations to your maps. Thank you very much for watching all of these videos. See you then.
For more resources, visit our website, where you can track your progress, access interactive quizzes and lesson notes, and connect with our teachers and other learners like you. And if you'd like a more guided experience, we also offer live online bootcamps with expert help. So join us at thegraphcourses.org to start your learning journey today.